Alright, in this section here we're going to be talking about rational expressions with integer exponents, and we're just going to be simplifying. So let's remember here what a rational number is first off. So a half is a rational number, 3/4 is a rational number, 2 is not a rational number, that is an integer. This is with integer exponents. So if I were to say x squared over y to the third, okay, this is a rational expression. We have a rational number here. And so x might be equal to 5 and y might be equal to 2, and we would plug that in and we'd have a rational number. Alright, we're going to actually start off with some stuff that's not rational numbers first off, so we can kind of do a little refresher here on adding exponents, subtracting exponents. Let's say, for example, I had 2 squared times 2 to the third power. So if we want to simplify this, we would say this is 2 because we have the same base, and you would add your exponents, and of course this becomes 2 to the fifth, which I believe is 32. But anyway, so we add exponents, okay, as long as our bases are the same. So if I were to have 2 to the fifth times 2 to the negative 2, right, bases are the same, you add exponents. This is 2, 5 minus 2 is equal to 2 to the third, which ends up being 2 times 2 is 4 times 2 is 8. Right? 8. Okay, now for an actual, maybe a rational expression here. 5 raised to the fourth power over 5 raised to the second power. Now I can take this and move this denominator up to the numerator. And when we do that, we change the sign of this integer here. It's a positive 2. When we take it into the numerator, it becomes a negative 2. And of course now, because our bases are the same, this is 4 minus 2, which can reduce down to 4 minus 2 is squared, and of course that's 25. So we have 5 4's in the top. We have 5 4's. We have 4 5's in the numerator and 2 5's in the denominator, and we just canceled 2 of them out of the denominator and 2 out of the numerator, and you were just left with 2. Alright, that makes sense, hopefully. Okay, something a little bit more complicated. What about negative? Well, I don't know if this is more complicated, but we're going to throw a negative in. Over negative 7 fifths. Now you notice we have 4 in the top, 5 in the bottom, so we can cancel 4 of those out in the top and 4 out in the bottom, and we would just be left with one of them in the denominator. Of course, you can always take this negative and bring it out front. Now remember, we can do this the old-fashioned way, taking this up into the numerator, but that becomes a negative, adding exponents, and so you have 4 minus 5, which ends up with negative 7 to the negative 1, but now we want to take this back down into the denominator, right, because it's a negative, bring it down, but we don't write a 1 here, right? But then we always want to bring this negative out front, okay? Alright, another way of looking at that. Okay, let's see. Let's do one more of those. Negative 2 squared over negative 2 to the sixth. Now there's 2 in the top, 6 in the bottom, so we're going to knock this out, or you know what, I'll just write it like this.